I'm going to discuss J advanced P by Q on gravitation. This is what, my dear? J advanced P by Qs of gravitation. Right? Okay. So student, this is the first question here. 1994. 2 marks. So what's question, my dear? Listen carefully. Okay. The magnitude of, I'll write questions to it. The magnitude the magnitude of the gravitational of the gravitational field at at distance r1 and r2 from the center of a a uniform sphere uniform sphere of radius r and mass m r f1 and f2 respectively. respectively. And this is a question is today. The magnitude of gravitational field at a distance r1 and r2 from the center of a uniform sphere of radius r and mass m are f1 and f2 respectively. Right. Then, then students, option first, f1 by f2, which is equals to r1 upon r2 if r less than r, and student, if r1 less than r and beta r2 less than r. This is first, student. Option number second. This is f1 by f2, which is equals to r1 square upon r2 square if r1 greater than r and r2 greater than r. Students, option C, f1 by f2, which is equals to r1 upon r2 if r1 greater than r and student r2 less than r. Right? Last option is student. This is F1, F1 by F2, which is equals to beta R1 square upon R2 square if R1 less than R and student R2 less than R. So this is the point, right, my dear? Okay, so I'll discuss here this question. It's literally a very good questions, right? So I'll go here slowly so that you can easily understand these questions. So what's this question, my dear? I hope you got it, everyone, right? So we'll go through the question first, all of you. Beta, we have to solve the question according to given data, right, my dear? Okay, I hope you have taken everyone. I can see a screenshot of this question. Now, student, I'm going to discuss questions here according to option wise. So, what's this questions, my dear? F1, you can say beta, first case. Let us suppose in solution student, this thing here I discussed today in classroom little, right? So this is for beta small r greater than capital R. Small r beta what? Capital R. The gravitational field beta this condition outside the sphere beta I can take, right? So this beta conditions you can simply write here. Gravitational field and beta or you can say gravitational force. So this is what my dear G small m upon beta. You can say this is what R square. This is what R square, right? So since beta, you can say because they mention here F1, F2. Let us suppose students F1, which is equals to GMM by what you can say beta is R1 square. GMM by what beta you can say R1 square here. So similarly, beta you can write for F2 also. For F2, this is G capital M with small m upon beta G R2 whole square. Right. Just take with a division of this one. Take ratio of this F1 by F2. So you can write easily. You can say easily. What my dear? This is R2 square upon beta G R1 square. So this is beta G, this condition here. You can say which option is correct beta. Okay, so this is condition here which you can keep in your mind. So F1 upon F2. F1 upon F2, right? Okay. So now beta we'll talk once. I can say about gravitational field. So beta today in the classroom here, I give the formula of gravitational field, right? So which I just beta this one here. So now I'm going to write a student. I can say gravitational field due to solid sphere, right? At end point. So this is what beta is. Gravitational field you can write with ya. This is I said in classroom here today. This is GM capital RQ into R right now. So basically, we wish to find basically condition of force. We wish to find force relation, my dear. Okay. So let us suppose you are talking about this case. Formula can apply R less than R because this is what R greater than R. This is what, my dear, R less than R. So R less than R beta. You can let us suppose F1 or beta. You can say E1 here. Right. What they have taken is it's magnitude of gravitational field at a distance R1 R2 from. Okay, beta. I can say it. This is force F here, but I can see in options they didn't consider student like say electric field. Means gravitational field E1, E2, E3 like. So same option will go through which. So what you can say which body for this condition? E1 you can write GMR1 upon what beta you can say? This is RQ. E2 beta, what you can see? GM. R2 upon which is R cube. Beta, just take ratio of this one. Just take ratio of this one, bacha party. Uh, Now, students, just take beta ratio here. E1 upon E2. So this is nothing beta. What you can say? R1 by R2. What you can see here? This is R1 by R2. So this is C option, students. Yes, you can see this option is correct here. Option number C. Option number C correct with the party. For I can see field here. This is but I can see Bombay correct here. R1 greater than R and R2 greater than R. Right. So beta will go through options number that is Bombay and Canada is correct answer. Right, bacha? Okay. Just move beta. Next question here. Next question, student. This J Advanced 2023. J Advanced bacha party that is 2023. Beta J 2023. Right. So student for this condition, what's the question here? I'll write once. Student two satellites, capital P and Q are moving in different circular orbits. Different circular orbits around around the Earth. Radius beta you can take R. The height of P and Q from the Earth surface are HT and HQ respectively, where HP R by 3, the acceleration of P and Q to Earth's gravity are GP and GQ. Student, if GP upon GQ 36 upon 25, what is the value of HQ? Right. So this is option, student. 3 r by 5 r by 6 6 r by 5 5 r by 6. So have a look, student. Question first. Uh, Two satellites P and Q are moving in a different circular orbits around the sun. Radius r. The height of P and Q from Earth surface are HP and HQ respectively. Jai Shri Ram, student. Uh, HP and HQ respectively, where HP is mentioned beta. Just highlight this point because we will use HP, student, that is R by 3. The acceleration of P and Q to Earth's gravity are Gp and Gq. If Gp and Gq is equal to 36 upon 25, what is the value of HQ? Okay, we wish to find HQ vector party. Okay, so again here, have a look of the questions. It's not tough at all, but it's good questions. Good in saying you can say like there is little calculations, not major tough and good questions. Okay, so student, have a look here for this question solution, student. Now I'm going to solve this question. Right. So it has the I hope all of remember here accelerations due to gravity at a height. So you can write this is G is equals to what beta? G effective here. I hope all of remember G upon 1 plus H by R whole square. Right. This is the formula beta. I hope all of you remember. G is what you can say G upon 1 plus H by R whole square beta. Okay, fine. So one thing is common for this question here. That is what you can say. You can make beta once diagram. You will take basic idea. You can make once diagram. Right. So you can say there are two satellites P and Q. P and Q. Okay. So I can see these two satellite beta. They are revolving. You can see this is Earth surface. This is what, students? This is, you can see, Earth surface. Students, what is the radius of Earth surface here? You can take R is the radius of Earth surface. This is, you can take it as satellite P. This is, you can take satellite Q. Height of P is mentioned R by 3. You can see from here to here. This distance from here to here. Yeah. This is mentioned for us. We wish to find what is the height of Q with respect to Earth surface. This is the question basically. I hope you also understand. Also understand. So now, student, I'm going to write your expression. This is what you can say for GP. GP beta, what you can write here? This is G M upon beta what? This is radius plus h of p beta g whole square, right? Similarly, beta you can write for GQ. This is GM upon what? R plus HQ whole square. Beta equations number one, equations number two. Just beta divide these two. First by second. So beta, if we divide first by second here, so what you can write over here? This is GP upon GQ. It's a reverse vector party. Finally, you can write. This is R plus HQ whole square upon R plus HP whole square. So GP by GQ. Beta mentioned in the question beta how much? S. This is 36 by 5 beta. So we can write, students, 36 by 25 is equals to R plus HQ whole square upon R plus HP beta whole square here. Then beta just 2 square root. So both sides. So you can say this is what? 6 by 5, which is equals to R plus HQ upon beta R plus HP. HP mentioned here, R by 3. So this is, students, 6 by 5 R plus HQ. So R plus R by 3, right? So here, student, just going forward here, solve R plus SQ. This is 3R, means you can say this is 4R by 3. So I'll continue here only because little, I think there is further calculation might here. So just to cross multiply, you can see 6 for the 24R. 24R is equal to beta 15 into R plus SQ. Just do a simple beta calculation here. 24R is equals to 15R plus 15 times of HQ. So beta how much here? Uh, this is, you can say beta 8R by 15 is equals to HQ, right? So bacha, no, this is 9 here. This is 9. What you can say beta? 9R by 15 is equals to HQ. 9 only. So cancel here. So we will get HQ is equals to 3R by 5. HQ is equals to what beta? 3R by 5 here. So any option S. Option number A. Option number A. So I can see it's an advanced question, but not much tough. Doable only. You can do these questions. Right. Advanced it's a J Advanced 2023. J Advanced student, this is you can see 2023. Right. So doable question here, I can see in the paper hall you can also do. Okay. Do beta one more question here. Advanced 2024. I'll not write beta entire informations, right? So this is students JEE Advanced Beta G 2024 year. Chapter, it's gravitation. Beta, just I'm reading questions one. A particle of mass capital M, sorry, a particle of mass M is under the influence of the gravitational field of a body. Okay, but I can say there is a point mass, but there is condition beta. This capital M is much greater than small m. This is the information in these questions, right? So keep in your mind. Okay. Beta, the particle is moving in a circular orbit of radius r naught. Radius beta what we can see, this is what r naught, right? And time period t naught whichever body around mass m. You can take whichever body. This is capital M, right? I can say there is satellite here, which is revolving like this is small m, like this. This is the question basically, which just give our time here. What's the mentioned in the question student? You can say r naught is what? Radius. Beta, you can take radius is what beta g? R naught. Time period also beta I can take here. This is what T naught. This is what T naught bacha. Beta, what's the major point of this question? Corresponding potential energy. What is student? Potential energy here. This is mentioned in the questions. Potential energy is a function of R. Potential energy is a function of R student. This is M into alpha upon beta small r cube. Means you can say potential energy is a function of R. Potential energy as a function of R. Right, my dear? Okay. Where alpha is what positive constants of a suitable dimensions here. R is the distance from the center of the orbit. Okay. If the particle moves in a same circular orbit of radius r naught, combined gravitational potential energy due to this. So we have to find which body in these questions. What is the time period? We have to find which what I can say time period here. So there is one more information which I can take in consideration. This is t1 square minus t naught square upon beta you can say here t1 square. This is the information over here in this question, right? Hare Krishna Devi beta. Yes, I'll take bacha. So now students, build this question here. I can write with options for these questions. So this is 3 alpha upon beta. This is GM R naught whole square. Next here you can say alpha twice GM R naught whole square. Option C students, alpha upon GM R naught whole square. Next beta is 2 alpha GM R naught whole square. Okay. Now Vijayji, have a look at everyone. The questions, how this is. Beta for this question here. Particle of mass m, right, is moving in a circular orbit of radius r naught, time period t naught with T. So simply beta for this solution here, we can use basic tools. If any particle which is if any particle which is revolving on a circular path, who will balance the motion of particle? Because no, if there are two particles moving on a circular path, so I can say centripetal is what provided by gravitational force. So one force is what? If any particle which is moving on a circular path, centrifugal force always acting away from the center. So you can write my dear over here. That is what centrifugal force here. Fc is equals to mv square by r naught. As I said, student, as I said here, there is a particle, mass is m, there is a particle, mass m beta. This is motion. You can say v. They are rotating in radius r naught here. This is the question basically. I hope all of you know. Now, with party, we have to write here the expression of what? You can say beta g for gravitational force. For gravitational force, bacha. So you can say Fg acting in this direction, Fg acting beta in this direction here. Fg beta g you can see towards the center, and you can see centrifugal force away from the center. So Fg beta you can write simply here. This is G capital M small m upon beta g you can say R naught whole square minus here. Thrice of beta you can say M into alpha upon what beta g R naught to the power 4 is equals to beta. This is mv square by r naught, right? Now, students, you can say simply, sir, this m finish from everywhere, right? This m finish from everywhere. So you can write beta in a phrase G capital M upon beta is r naught whole square minus here thrice of alpha upon r naught to the power. This is what beta is 4. Then which you can say this is V square upon R naught. V square upon R naught. Right. Students, for this condition, you know why I wrote this thing here? Because in the question mentioned, it's a potential energy. It's about potential energy, bacha. M alpha upon R cube. So I use the basic formula beta. So now, students, I can see further. We can just move proceed because we wish to find time period relation. So now student, I'm going to write. I can see this is step 1. This is student step 2 here. So omega 1 whole square upon beta is omega 2 whole square. Or you can say omega for the particle here. This is revolving on a circular path. This is what, my dear? You can say Gm. This condition here. Gm upon what? R naught square. Gm upon beta R naught square minus thrice of alpha upper beta is the R naught to the power 4. Upper beta, this is initial here, particle in motion. So Gm upon beta R naught whole square. Now students, you can say simply here, R naught square cancel everywhere. R naught cancel everywhere. And beta, this is time period beta. I can say angular velocity in step 3rd here. We are interested to find what, my dear? We are interested to find basically, my dear. I can say that is what time period. So you can say over here because this is a relation here. I can tell once. Time period inversely proportional to omega, right? So here I'll say T naught square upon T1 square beta g. This is what, my dear? Just reverse of this here. 1 minus 1 minus 3 of alpha. Just beta, just because we'll take LCM here. So these all terms cancel each other. Thrice of alpha, which this is Gm into R naught whole square. So this is the last one which I've already. So for this condition here, finally, just we'll go this side beta, this minus one. So what you can say, one means beta. This is T1 square. This one, this side here, minus minus plus. So T1 square minus student T naught square upon beta, what you can say, T1 square, which is equals to 3 alpha upon beta g. This is GMR naught whole square, right? So now, bacha, we'll go through this here because we wish to find this one only. T1 square minus T naught square upon T1 square is equals to thrice of alpha GMR. Yes, yes, beta. We have option first. You can say we got finally out answer first here, right? Now, students, let's move next question here. It's literally a good questions for gravitation. For gravitation. Okay. I hope you done with your party. Okay, yaar. Happy with next year. Move next questions. Student, for this question here. Uh, yes, there is one more good question. Yes, sir. I wanted to discuss this one also. Hmm. JEE Advanced 2012. Yes, beta. Yes, JEE Advanced 2012. Have a look here. What's the question? It's a small question, so I can write it. Student, God bless you for your reply. Bacha ji, for this question here, I can say, hmm, what is the minimum energy? I'll write here this question. It's a short energy question. What is the minimum? What is the minimum energy required to launch launch a launch a satellite of mass m from the surface of planet planet of mass capital M and radius capital R in a circular orbit at an altitude. It's not easy question there, tough question here. At an altitude, of 2 hours. At an altitude of 2 hours. Now, let's have a look at options. This is 5G, my dear, small m, capital M upon 6R. Now, options we are studying. This is twice G, small m, capital M upon beta G, 3R. Option C, G, small m, capital M upon beta G 2R. Last options G small m capital M upon beta G 2R. So this is the question basically, my dear. Again, I'll read here once. What is the minimum energy required to launch a satellite of mass m from the surface of a planet of mass capital M? Do underline this and highlight the surface of planet mass capital M beta and radius is what? You can say R in a circular orbit at altitude of 2R. At altitude of 2R. Right. Now, students, I can say for the questionnaire, just we'll go through this. Student, they mentioned here condition of I can say beta for satellite. Condition for beta ji, satellite here. Right. Do one thing, beta ji. What's the answer of the question? I don't know. We'll go through this. But beta, what's the thing here which you can keep in mind? That is first beta in step one. What is the formula of gravitational potential? Because they are talking about minimum energy. They are talking about what? Minimum energy, right? Now, students, I can say for the question here in step one, what I discussed gravitational potential energy. Today, beta, I gave this formula in the classroom here. So, gravitational uh, potential energy, gravitational potential energy, right? For a pair of mass beta, what we can say minus G capital M small m upon R, right, bacha? Okay, next bacha जी orbital velocity here. Maybe all of you remember because everything we have to discuss for an altitude, for an altitude, right? So what is the velocity here? Orbital. Maybe all of you remember. Otherwise, I'm telling you, this is nothing there. You can say G m by R. Right. So student for this condition here, because they are talking about at an altitude. So what you can see, this is R plus H. Orbital velocity, not escape velocity. Both are different velocity. Okay, fine. So basically, we wish to find what is the energy. What is the energy, students? Right. So you can say beta for this condition, we'll go through this here. We can write in step 2 beta for energy final expression. So this is half m into beta. We notice one. I hope all of you remember. Yeah. K initial, U initial, K final, U final. This one beta very famous for everyone. I hope all of you remember. Half m V naught square minus G capital M into small m upon 3R. Right. So kinetic energy beta. This is energy final here. So we can solve beta G further. Energy final. What you can see half M by party. And this H, how much mentioned here? This is 2R. 2R plus R beta. What we can see? 3R here. It's entire square Vector party. So you can write Vector party. This one. This is, my dear, you can write further. This is G M by what beta? This is what? 5R. 5R or 3R? Beta 2R plus R. It's 3R which is the only. So entire square Vector party. So what you can say? G M by 3R minus Chapati. This is G small m capital M by 3R. Beta do just a simple calculation here. So 3 to the 6 bacha. So G capital M small m by beta G 6R minus G small m capital M by 3R. Right. So further student, just take LCM here. So what you can see? 3 to the 6 only. You can write which this is what 3 to the 6 only here. So this is you can say 6r and this is 1 minus which are so you can say here so 2 1 minus 2 minus 1. So minus G capital M into small m upon beta 6r. I forget to clear this question beta asked in JEE beta advance 2012. What might be J advance 2012, right? Okay. So bacha party we can write here further minus GMM by what bacha ji we can say 6r. This is energy final. This is energy final. So beta what we can write finally here? Beta. Now I'm going to step 1 to beta finish. Step 3 students for this question. Here I'm going to write what is energy initial. What is energy initial bacha? So this is what you can say minus G capital M small m upon R plus beta something here we in the terms of kinetic energy. In terms of kinetic energy. Beta energy we wish to find minimum here. So what is value of K? So finally bacha in a step 4 just subtract beta these two here. So what you can say energy initial is equals to energy final. Energy initial beta this one. So minus G small m capital M upon R final chapati plus K R minus already just now I calculated G small m capital M upon beta G 6R. So just do beta further student. So we'll get here value of K minus G small m capital M by 6R plus G small m capital M by RR. So you can write K is equals to 5G small m capital M by 6R. So which option correct is S beta? This is options A is correct. So it's a questions of advance. Sometimes literally they ask their fundamental questions, right? They ask the student fundamental questions here. So my mean to take here just at home do hard work. Literally, beta, it's highly required here. Do hard work bacha, to learn the concept. It's highly required. Okay, next beta questions here. I can see we'll go through this. What is the next question? Just give me a second. Oh, no, it's a system of particle. Yes, beta. Questions number beta again here. I can say for advanced. Beta next question I can say student that is what advanced questions here. For 2017. Yes, beta. This is JEE advanced 2017. Right. So what question says here? Just I'll read only. A rocket is launched normal to the surface of the Earth away from the sun. Along the line joining the sun and the Earth, the sun is beta. You can say mass of sun is what, my dear? 3 into 10 to the power 5 times heavier than Earth. Beta, this is mentioned in the question student. And distance is larger than radius of Earth. So beta, I can say distance is mentioned student. This is 2.5 10 to the power 4. That is larger than radius of Earth. 2.5 10 to the power 4. That is larger than radius of Earth. The escape velocity of Earth gravitational field. Beta, that is true here only. VE 11.2 kilometer per second. Yes, beta. If you will give this much velocity of any particle, so particle will escape from, I can see, environment of Earth surface. Environment of Earth surface here. 11.2 kilometer per second. The minimum initial velocity required for the rocket to be able to leave the sun and Earth system. Okay, beta, how much we have to give a minimum velocity to a rocket so that rocket can leave the environment, you can say sun and earth system, right? Closest to. But there is options here which I can write. So what is the velocity of satellite? This is students 22 kilometer per second. Bombay students, velocity of satellite 42 kilometer per second. It's Canada, velocity of satellite. This is 62 kilometer per second. Last beta G, velocity of satellite. So you can write 72 kilometer per second. Right, this is the question here. So we'll go through this here. Again, it's not a big deal to do. You can do bacha. It's literally very easy questions. We wish to find what's a will give. We have to avail energy of a particle. So that particle will escape. I can say environment of Earth surface. But just be clear. You can understand throughout the diagram. Yes, this is Earth surface. Right. Radius of Earth beta. You can take R. Basically, this is the satellite. You want to throw, let us suppose, I don't know what is this. We wish to find this is the what is the value of this one minimum so that I can say this particle should like never come back. So beta we have to find this Vs only, right? So simply beta we can apply student. That is a very common song here. I hope all of you remember. Otherwise, I'm repeating. Yes, beta, just apply it against it. Wait, work energy theorem. So here, students, you can see if we have only conservative force, I said multiple times in the classroom. If we have only, if we have only what? Conservative force, right? So what student you can write? Kinetic energy initial plus potential energy initial is equals to kinetic energy final plus beta g potential energy final, right? So simply, bacha. So what is initial kinetic energy? Yes, this is it. Half m into half mass of satellite into beta what? Velocity of satellite whole square. What is energy here? G m1 m2 by r. This is G mass of Earth into m upon bacha party r e whole square. Sorry, extremely sorry beta. Gravitational potential energy G m1 m2 by r only. G m1 m2 by r only beta. Okay, which is equals to beta kinetic energy final zero bacha. What is the final kinetic potential energy here? What is the final bacha bodies? What you can say? This is uh, bacha ji G minus one layer G into beta. This is M E beta. Okay, do one thing here because you know if finally beta arrived, I can say above. I can say beyond the environment. So for that case, yeah, these two are zero zero. These two are zero zero here. Means kinetic energy also zero, potential energy final also zero with jet. So you can write simply with half m into beta vs whole square. This is g into me into m upon which g what you can see re whole square, right? Further, everything mass condition is mentioned with body. So beta will use this condition here only. So this is student half m into velocity of satellite is equals to g me into the mass is mentioned here. How much times? M into 3 into 10 to the power 5 times. And beta radius here, what you can say, this is more than that, 2.5. This all data beta mentioned in the question here. 2.5 10 to the power 4, right? Into bacha ji RE. That much here. Just simply beta. Just calculate further. So you can say bacha, this M finished. So what you can write finally with about it? Vs whole square by 2 is equals to G. G beta how much? 6.67. 10 to the power minus 12 here. Mass of Earth. Beta, what is mass of Earth here? Mass of Earth. I'll see later. Beta, this is mass of Earth into beta 3 into 10 to the power 5 upon bacha radius of Earth 2.5 into 10 to the power 4. Listen carefully here. You can say, student, this is what? Cancel, right? You can see this is 30. So this is Vs whole square by 2, 6.67, 10 to the power minus 12 into beta the mass of Earth. So this is what? You can tell beta the 30 upon here 2.5 and radius of Earth 6400 kilometer means 10 to the power 3. So we can say 3 plus 2, 5 will goes up 6. So Vs square by 2. We have one more here. You can see over here. So 667 by 25 into 64. 10 to the power minus 12. And this is 3 plus 2, 5 plus 2, 7 plus 7 into mass of Earth. Further, let's just take 32. So further, just solve student 667 into 10 to the power minus 5 only. Minus 5 into beta mass of Earth 25 into beta 32. Further solve it and finally I will get answer of the questions. Just give me some time to just calculate. Yes, approx beta. Mm, approx beta ji you will get that is 42 meter per second. So answer in which form mentioned here? Just once check. Okay. Student, I can say answer here that is kilometer per second. Bacha. So you can write it. This Bombay is the correct answer. You can write student that is Bombay is the correct answer for the questions. Right. Do beta one more question here that is very common. That is very. It's not beta PYQ. Student, it's not a PYQ, right? But it's very informative questions here. Yes, they will give you multiple information in these questions. Yes, Bacha. It's not PYQ. So listen carefully, student. A satellite revolves around a planet in a geostationary orbit of radius capillary. Right. No, beta, what is the geostationary satellite? What is the meaning of geostationary satellite? Right. Beta, Earth must be what? Rotate, and I can say beta, this kind of things here. You can take geostationary satellites. Right. So what the question says there in this question, geostationary satellite, if angular speed of a planet is about double due to what? Some reason here you can see, find the new radius of orbit of geostationary satellite. Okay. So beta for angular speed here, just go through beta solution of the question. I'll write once here. This question it's not very tough. A satellite, a satellite revolves, a satellite revolves around a around a planet in a geo geostationary satellite geostationary satellite geostationary satellite orbit orbit of radius capillary if angular speed of planet about its axis is doubled due to some reasons. Find the new radius of the orbit of geostationary satellite. Now, yes, beta, come. A satellite revolves around the planet in a geostationary satellite orbit of radius r. If angular speed of a planet about its axis is the double, yes, beta, due to some reason. Find the new radius of the orbit of geostationary satellite. Okay, so have a look at the solution here for these questions. For geostationary satellite, angular speed of right, angular speed of satellite is what? It can write simply here. Angular speed of satellite, that is 1 upon r into beta gm by r. Right. This is what you can say satellite angular velocity or angular speed of you can say planet. This is what, my dear, angular speed of planet. Okay, after increasing in planet angular speed, because they mention it well, what says if angular speed of a planet about its axis is doubled after increasing, after increases the planet angular speed beta, right? For this condition, what we can write? This is beta. You can say step one. This is step two beta. It's omega prime. Omega prime for what? Satellite. For what satellite here? This is 1 upon student, you can say R prime. This is Gm upon beta R prime. Right. This is what mentioned. Twice of angular speed of planet. This is mentioned in these questions. Student, if you remember carefully, beta C, these two values here. Omega planet we have already from here. So we can beta this value, you can just feed over there. You will get answer. So students in step 3 here, what you can say 1 upon r prime root of gm upon r prime, which is equals to twice beta. You can say 1 upon r root of gm by r, right? So, bacha, just further you can say, sir, this is finished. No need to worry about at all. Then beta, you can say this is what? 1 upon r dash to the power beta what? 1 plus 1 by 2 here. This is 3 by 2. Twice into beta. You can say here the same condition of beta. This is RR. Or do one thing here. Better for us. Do a square root both side. God bless you for your reply. This beta do, I can say beta square root both side here. So what we can say? This is, you can write Pachapati R prime whole cube. R square into R prime whole cube. Which is equals to, you can say, R cube by 4. So we wish to find here R prime. So what we can say? R upon 4 to the power 1 by 3. So this is not tough at all here, but little you can say questions look like this only. Okay. Bacha, move here. Next questions. Yes. Beta, take snapshot once here. Student, take snapshot once. Yes, take snapshot once. Hmm. Next question, student. Okay. Uh, this question here, I'll go through diagram only, beta, right? Because I don't have much time here. In any case, I have to just terminate this session 9 o'clock. Beta, if a diametrical tunnel, it's literally a good question, bacha. If a diametrical tunnel is made in Earth, student, you can take this is Earth. It's a good question here. Tunnel problem. It's standard student. So, student, you can write over here for this condition. This is a tunnel into the Earth. This is what you can say tunnel into the Earth. So, if a diametrical tunnel is made in Earth and tunnel, along the line of tunnel, a particle of mass m is released from a point A. Bacha, you can just go through this. Student, this is a point A, right? Later, this is radius you can take R, particle released at point A. So this radius to till now you can say Earth's surface. This is 2R, my dear. Mentioned in the question set is as well. So if a diametrical tunnel is made in a earth and along the line of a tunnel, a particle of mass beta, you can say that is what m. Particle of mass. Particle of mass beta, you can take a small m. Beta earth mass, you can take capital M. Released from point A at a distance 2r from Earth's surface, as shown in the figure. Find the speed of particle when it would be passing a point B. So, student, there is a point here. Just take in consideration. This is the point. So we have to find beta what is the speed of particle. If this particle crossing point B, any of the particle, you can take point B only. Right, inside the tunnel at a distance r by 2. Okay, this distance which I can say from here, yeah. This distance which I can say what r by 2, r by 2, right? So we have to find the speed of particle. Find speed of particle at point B. So now, student, I'm going to write everything. Yes, beta. Solution here in step one. I'll go slowly here. It's a good question. Particle at A, bacha. So you must write what is the gravitational potential, because no, due to this particle beta, what's the potential here? So gravitational potential at point A, gravitational potential at point A, bacha. What is formula for beta for gravitational potential here? I'm writing bacha part A. V is what? Minus gm by r, minus gm by r. So V beta I can say what? Minus g beta, this is capital M by beta g 3r. This is here. Then beta, just write gravitational potential at point B. No beta, this is the point here. You can remember everyone. Gravitational potential inside the Earth's surface, or you can see solid body, right? Or solid sphere, which what's the formula here? Minus gm by r. I'll write the formula here. Minus g m by, this is 2r cube. This is what, my dear? 3r square minus your r square. If you remember this formula, it's highly because I can remember important student. So VV, you can write here this condition. Everything remains same. This R you can replace by what? R by 2, because this is the formula we can use directly. Gravitational potential inside point of Earth surface. So this is what, my dear? This is G into beta M upon beta G 2R cube into beta, I can say 3R square minus R square by 4 beta. Means near R by 2. So no need to more confuse. So potential at point B, bacha. What you can write? Minus Gm by 2R cube. Just take LCM here. It means 4 only. 4 is 12. 12 R square. 11. You can say bacha 11 R square here. So this is the potential we found at point B. Right. Apply bacha party, I can say formula of what? Energy conservation here. Because we used to find speed. So we don't have any another choice. So we have to invite normal song here. If we have only conservative force, kinetic energy initial, potential initial, kinetic energy final plus potential energy final. If you remember everyone here in the classroom, I gave Ramban formula. Students in the classroom here, I gave Ramban formula. What is this? That I can say potential is equals to potential energy per unit beta charge. You can replace same thing beta for gravitation also here. Minus times work done by conservative force per unit charge, or you can say work done by external agent per unit charge. Right. So this is the part beta which you can keep in your mind. So here beta I can say gravitational potential. This is gravitational potential energy, and mass you can charge you can replace by mass. Charge you can replace by mass. Right beta. So particle what is initially has at point A only you can say beta gravitational potential energy here. So we can simply write what's the party? This is M into VA. Or I'll write here only. I don't have much space over there. Kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. That much here. So initial energy zero bacha party. We can write here initial kinetic like beta. This is energy here. That is potential energy bacha. So just use beta this formula here. Potential energy we can write here what? Gravitational potential energy. Gravitational potential you can write gravitational potential energy per unit mass. So beta I'll use beta party this formula here. This is what beta I can say M into VA, which is equals to beta. You can say half mv square plus what's about it? M into gravitational potential energy at point B. If you remember here, V and B both are negative, bacha. You can see M, happy birthday everywhere. So minus students Gm by 3R, which is equals to beta, I can say minus 11 Gm uh, beta R cube near. So this is cancel finally 11 Gm by beta what you can see this is what 8R plus beta G half V square. This I interchange here. So here you can do bacha this further solve here. This will come this side minus 3 sorry minus Gm by 3R plus 11 Gm by 8R is equals to half V square. 8 3 the 24, 24R. So this is what I can say about here. 3 8 the 24 na? Uh, this is 8 3 the 24 which is 8 na yaar. So this is you can say beta minus 8 times of Gm and this is 3R. So you can say what 33 into Gm bacha is equals to what 1 by 2 V square. You can see bacha this is cancel here 12 times. Right. So, and this is 25 here. So finally, you can say beta V is equals to 25, 5 only. 5 by 2 to the 4 here because it's 12. Yes, beta. So 5 by 2 beta, and this is because it's 12, right? 2 to the 4 is the 12. 2 to the 4, 3 to the 12 here. So you can say this is Gm by 3 here. So this is the student answer for this question here. Yes, beta. This is answer for this question here. So not tough at all. I can say I have to do more questions. If I'll get free, then I'll do more questions, student. Now, this is all about, I can say, gravitation, PYQs. I'll see you student in next class here. Now, I'm going to stop live session.